Now, what is the process about and how are we going to work with this? So first, we need to understand how a microservice-based architecture works. So when I started my class, initially when I started my class, I told that we started with monolithic architecture. I told that when I talk about monolithic architecture, it means everything will be put in one single machine. And the problem with this one single machine is that if this one single machine is gone out of order, everything is gone. Okay, something like this. So I gave example of a Uber application where everything was put under one single environment. So we go ahead and put everything in separate machines and separate environment. So that separate environment is known as a virtualized environment. And to make this virtualized environment work, we came up with Docker containers. So each Docker container is a separate virtualized environment or a separate container, which can run independently and do everything of its own. But when you start your work, okay, there are few challenges which you will face. Like when one container, or let me say pod, when one pod is talking to another pod, okay, there can be issues of encryption. Okay, it means in my application, let me say I am using an application like Amazon.com. So I added something to my cart. Once I added something to my cart, I will go for the payment page. In the payment page, you will see, you will enter your credit card details or debit card details. And finally, that credit card or debit card will go to Visa or Master. And from there, it will get validated and you get the amount deducted. Okay. So in that scenario, if you see, the data which you are passing from your microservice to some other microservice should be encrypted. Point number one. Okay. But here in Kubernetes, we do not talk about encryption of the data which is moving from one microservice to another. Within the cluster, yes, I am taking care of everything. But if the data is going outside my cluster, then I'm not talking about it. Okay. So what am I talking here is, let me just explain this diagrammatically, and then I will come back and further talk about it. So let me say this is my Amazon application. Here I have three microservices. One is the web, where you do the shopping. Then you have the cart, where you do add to cart. And then you from add to cart, you do buy now, and it takes you to the payment page. In the payment page, you go ahead and run you go ahead and put your credit card or debit card detail. Done. But this payment page or this payment detail is put somewhere else. Let me say you are using a Visa card. So it is going to Visa. So this credit card detail which you have passed, it will go to Visa, get validated, and the amount will be deducted. Once the amount is deducted, then the order is placed. So this is order, right? Now, I spoke about various things, but I never spoke about this data movement, the data movement which is happening outside the cluster. We never spoke about that. But if you are a client, you will definitely want that this data movement should also be taken care of. So I will say this is one Kubernetes cluster or one application. This is another application. So when data is getting transferred between these two, it should be encrypted. So the first point I have raised here is about encryption. Okay. Then what's the second point? Now, assume that there are a lot of payments happening. Okay. Because a lot of payments happening, probably there can be a scenario that this particular instance which I have, this particular instance, this Visa wala instance which I'm showing you here, is not able to take the load. So you need to auto scale here. At the same time, you need to do the load balancing. If this application fails, the automatic failover should happen to this guy. Okay. So failure. And in case there is a failure, you need to do a re-entry. So within the cluster, we are checking everything. Okay. But when the data is flowing out, we did not talk anything about that, but now we are talking about that. We are talking about the encryption here. RYPTION. We are talking about encryption here. We are talking about load balancing and auto scaling here. We are talking about failover and re-entry here. In case there is a fail, there should be a restart logic. We did all these things inside the cluster, but when the request is going outside, I never spoke about that. So now we are trying to address these problems. So, and the last thing is, and now the last thing is, in case there is a failure, so I should be able to monitor that. I should know where it has failed, why it has failed. So this monitoring thing also, I should be able to do it. Okay. On top of that, if I have to collect any data metrics, any entry metrics I need to collect, or I want to restrict users, so access issues. If these kind of things I want to implement, I have to use a new service, which is called Istio. I will repeat. Now, let me say I'm running a application like Amazon.com. Amazon.com has a lot of services, like you can view a product. If you like, you can select that product. Once you select, you can add that product to your cart. From your cart, you can buy that item. But when you go to do a payment, the payment will happen at a different place. That may be Visa, Master, Amex, depending on what kind of credit card you're using. So whenever the data is going outside, this is the point we are talking about. Whenever the data goes outside, it must be encrypted. The first point is it must be encrypted. No website will ever want that you send unencrypted data. So the first point we spoke is encryption. Second is when you are sending the data to the other server, let me say this is Visa payment server for me. If you're sending the data to Visa payment server, I need to check whether this server is healthy or not. If it is not healthy, I need it to auto scale. A failover re-entry should happen, a restart should happen. Okay. In case automatic restart is not happening, auto scale is not happening, I should be able to monitor, or I should be able to see what went wrong. And in case I want to restrict certain users, I should also be able to do that. So all these things, okay, if you want to implement, then you cannot implement directly on your normal Kubernetes thing, which we have learned till now. We will need something called Istio, okay, or it is also known as Istio sidecar. Okay, now let's go to the definition of this guy, Istio sidecar, and try to understand what is this. So let me come here. This is Istio official webpage. It says an Istio service. So it's a service mesh. Okay, so service mesh. This is a new term which is coming in. Is logically splitting. So this service mesh will split into data plane and control plane. So let me show you here. This is control plane and this outside is data plane. Okay, so this control plane, okay, contains Istio D, or you can think the basic building block of Istio. So I'm not that interested in that also. I'm interested in here. The control plane manages and configures the proxy to route traffic. How the traffic will flow. Is the traffic encrypted or not? If it is not encrypted, only certain users will have access or not. What is going wrong? So all these things are taken care by my Istio control plane. Okay. Then it has a data plane, okay, which contains something called sidecar. Okay. So it says it is a set of intelligent proxies, which is also known as envoy proxy. And this helps to control all the network communication between the microservices, because the data has to be encrypted. So these are the parameters which you need to keep in mind. Data encryption, routing policy, load balancing, failover. Then if there is a failover, there should be a re-entry. Access control should be there. And finally, you should be able to check the logs in case you want to check the logs. So there is a new term coming here called service mesh. So if I simply come here and say service mesh Istio, what is this? Service mesh. So here, okay. So it says Istio will address the challenges that a developer faces, or the developer and the operator faces, when a distributed or a microservice architecture is implemented. Whether you are building it from scratch or migrating anything, you will get help from Istio. So what all help Istio is going to do? So if I come here, it will help me in these ways. It will do the traffic management. Means if the request is going from microservice A to microservice B, it will make sure that it is going properly, the traffic is being routed properly, the load balancing is working properly, and more importantly, the data is encrypted. This is the first task it will do. In case there is a failure, it will maintain the observability. Means in case something fails, I should know why it has failed so that I can debug the scenario. And the third is security capabilities. Under any circumstances, my data loss should not be there. Data theft should not be there. So all these things is done by Istio. So Istio basically deploys something called Envoy proxy. Okay. And with the help of Envoy proxy, multiple micro-based services can talk with each other. Now, think of a scenario where you are asking your developer to write code for all these things. Okay. So my developer has to do two things. Give me 1 second. Okay, so as a Kubernetes developer or a Kubernetes administrator, I have to work with two things. One is functional requirement. Functional requirement is like, suppose I am building a shopping cart. Wait. Okay, so as a developer, I will have functional requirement. Functional requirement is nothing but if I'm building an application or a microservice for shopping cart, then item should be added here. Item can be added. Then you can buy now, save for later. So these are functional requirement, or these are the requirement as per the client. But next time if I log in, I see the same setup. This is not a functional requirement. This is a non-functional requirement. Security, monitoring, load balancing. So basically these points which we are highlighting here, okay, these come under non-functional requirement. These are non-functional requirement. So as a developer, I can concentrate on this. But if you ask me to concentrate on this also, it is an additional burden for me. So Kubernetes understands that, And all these problems, which we collectively are saying is non-functional requirement, we deploy something called envoy proxy or Istio service mesh. Everything, the word is here and there, but Istio service mesh. Okay. And you will see that all these non-functional requirements will be taken care by this envoy proxy or Istio service mesh. Now, if I come back here, you will see the service is there, and inside that service deployment will be there. Inside deployment, replica set will be there. Inside replica set, pod will be there. Inside pod, containers will be there. They will do their own work. But on top of that, we are having something called envoy proxy, which will take care of all the non-functional requirements. It will collect all the metrics and it will send it to the control plane, so that Istio control plane, this is not master. In my Kubernetes cluster, I had master node or control plane. It is not that. This is different. It is Istio control plane, or you can say this is Istio application. So Istio is something which is running on top of Kubernetes cluster. Okay. So this control plane is not your master node. Please be very careful about that. So this Istio control plane will see whether all the metrics are up to date or not. All the security aspects are taken care or not. So as a developer, you only concentrate on your application, on your functional requirement. All the non-functional requirements like load balancing, security, encryption, monitoring, failover, if there is a failover, restarting of application, all these things will be taken care by Istio. Okay. Now, if I have to start with Istio, I will start here. So this is the documentation. Now, if you want, the first thing what you should do is you should install Istio. So you can come here and say, I want to install Istio on Kubernetes. Don't run it on your free interactive shell. It will not work. It will need a lot of CPU, lot of RAM. So if you are running it on a normal page, it will not work. Come here, go to this page. Here it talks about how to download Istio and do all those things. What I will do is I will rather come here and go to the latest release of Istio, and I will start from there. Click on this. So here, if I see Istio 1.152 is the latest one. Okay, so I will be running this. Here, I can see this is the one which I can use for my Linux machines. So I can start my work now. Come here and log into your GCP account. So GCP console. So this is my GCP account. Come here. Okay. Now, if you click here, you will see there is something called project ID. Make sure that you copy this guy. So let me just copy this guy. Okay. Demonstration. This is the project ID. Copy the project ID. Now, go to my GitHub link. I will share this link with you. There is something called microservice demo. This is the one. Open this guy. This is the one. So here, this is the entire microservice application which we are going to run. I'll go step by step and tell you everything. But here, I am going to build an online application which will look something like this, online boutique. And here you will be able to see this guy. It will be something like this. It will be on Google Cloud. And here you can buy items. Obviously, it is not like you cannot use it for commercial purpose, but the commercial website which you will be making in future will also look like this only. So let me just go ahead with this, and then I will explain all these things, because the installation will take time. When the installation is happening, that time I will go ahead and talk about this. So this is our application which we are going to build. So we have a website like Amazon and Flipkart. Here, it will be running on cloud environment. It will be a microservice based architecture. there will be 11 tiers or 11 layers of microservices which will be running. And it's a web-based e-commerce application where users can browse, then add their item to the cart, and finally they can purchase them. Okay. So this here, I'm using my Google Kubernetes engine. Then I will use Istio, and there is Stackdriver for my monitoring, and on gRPC also will do the same thing. So these are the applications which we are going to do. So it is easy, and you will not need much of a command. You don't have to memorize everything basically. Okay. So I will show you this on there. But before doing all those things, let's start here. So it says open it in Google Cloud Shell. So you can directly come here, or you can come here and just click on this link, and it will bring you to, sorry, it is bringing me here. Give me 1 second. Let me go one step back more here. So I will open it, right click, open in new tab. So I'm opening my Cloud Shell here. Confirm, yes, I want to open this. So it will open. Now I will follow these steps one by one. So it says, first step is this guy. You need to mention your project ID and this thing. So let me take this guy. You need to mention your project ID. So if you remember, sometime back, I just copied my project ID. So this is my project ID. Copy this. Can this be installed in AWS? This can be installed on AWS. So the only thing is you have to run those commands on AWS environment. That's the only difference is what you're going to get. Give me 1 second. What is it? This Cloud Shell is coming like this. Wait, let me close this guy. I don't want to open it here. I'll open it here only. So let me open my Cloud Shell from here and maximize this guy. Maximize this guy. So I've opened my Cloud Shell. This is what I'm trying to open. Okay. Any compatible with GCP? See, I told you anything which you're running on GCP environment, the same thing will run. I will tell you what all will be different. So let's start first. So this is my project. So let me just put this project here. Now, the project ID is this. Obviously, it will be different for you. So once I have this, I will take this guy and I will come here and put it like this. First, let me do CD. See if it can, it is maximized. So CD means it will come to the first directory, then come here and say paste. So I'm saying project ID is this, whatever you have. Now, the second command it says is you have to run this guy. So let me copy this guy. So basically, this is trying to set the project, and then it is going to enable the Google APIs. So it says authorize. So basically, you are allowing your GCP to, or you're allowing your Kubernetes to access all the GCP related environment. So these two things are done. Project ID is from Kubernetes. No, project ID is from your this. So whenever you start your work on this thing, GCP, you have to create a project. And when you come to this project, it is associated with a project ID. So this project ID is related to your project or to the work which you're doing on GCP. It is not yet related to Kubernetes. If you want, I can come here and click on Kubernetes, and you will see as of now, I do not have any Kubernetes engine. Whatever I had earlier, I have already deleted them. See here, it is blank. There is no Kubernetes engine here right now. So the second step which I'm going to do is, so this is my step 1. It says create a Google Cloud Platform. So this is done. Then it says clone this repository and go inside this particular this thing. So anyhow, I want this code. So I will clone the repository and I will go inside. So let me come here. Okay. So let me go back here. And this is my Cloud Shell. Now from here, whatever I'm doing, git clone and all those things, now, irrespective whether, okay, so let me come here and say rm minus rf. If that thing is already there, then it will get deleted. So I already had that, so I'm deleting that. And I'm running this command called git clone. So basically what I'm trying to do, I'm cloning the project. Whatever the project is already there, I'm cloning that. And in that project, ls minus l, let me clear all these things first. In that project, ls minus l, you will see a lot of things are there, but I'm interested in this microservices demo cd. Go to this folder, microservices demo, and here your exact code will be there. Now, if you're working for a team, okay, definitely the developer will write and give this code to you. Now, in this code, you will find almost everything, but I am interested in this Kubernetes manifest file. In this manifest file, I will find all the things which I need. When I say all the files which I need, I am basically talking about my YAML files. So let me clear this again and do ls minus l. So you will see I have my, so these are 11 applications which I'm going to run. So for each application, I have one YAML file. Suppose I want to see what is this in cart service, okay, or checkout service or currency service. So you can very well go inside and you can see what is there inside that thing. If you're working for a big team, 99% it will be written by a developer. So here, if you see, there is a service file which is mentioned. There is a name given and the type is cluster IP, and this will run at 5050 port number. Then if you come here, you can see apps v1. It's a deployment file. The name is like this. And in the match label, it is saying the match app label will be checkout service. And then the most important thing here is that here they are using container, and in the container, they're using an image, which is a custom image, checkout service. So all these images are available on your GCR or Google Container Registry. Now, in your real world, these containers will be developed by the developers. Okay, so if developers will be there, they will write the code for you. In case the developers are not there, then also I feel the developers will only write the code, because the code which is written here, or in general scenario also, whatever code you are seeing here, see here, it's a combination of Python, Golang, HTML, C#, Dockerfile, Shell, and others. So 99.9% there will be developers, proper developers, okay, who write functional codes. They will write the functional codes, they will put it in a container, and then they will give it to you. Once you get the image, let me say they are using GCR or Google Container Registry, they will push the images in the Docker Hub or GCR Hub, wherever it is. From there, you have to take the stuff and start. Alternatively, they can ask you to write the Docker file. So you know how to write a Docker file. So you will have to write the Docker file and create an image out of it. But whatever happens, you will not sit and write the code. That is 100% true, because you are not a Python developer, a Golang, HTML, or a CSS developer. So these things will be given to you, okay? And based on the code, you will have to take the code and you have to create a Docker file, then an image. Then again, it will depend whether it has to go to a GCR or a Docker Hub. Based on that, it will be pushed to some repository. And from there, you will write the manifest or the YAML files, something like what I am showing right now. Let me, what is gRPC? Wait a second. YAML files will be written by developer. Yes. What are the gRPC in YAML files? Let me come and see what you're talking about here. Where did you find this gRPC thing? Wait, let me find it here. Kubernetes manifest. And I am here, card service. Where did you see this? gRPC. We need to see it, man. This is a name. This is a name given. The port name is given gRPC. You give any name of your choice. That will be your call. Give me 1 second. Okay, so this gRPC is nothing but a name. You give any name of your choice. Now, once this is done,
Can you put it?
come back. So this clone is done. It says you be in the microservice, this thing. And then it says you go ahead and create a GKE cluster. So either you can go ahead to your console and create it, or you can create a autopilot mode, or you can create a standard one. So whichever is suitable for you, you can do that. There is no restriction. It will run in GKE cluster or your AWS cluster, wherever you want. You go ahead and create a cluster. So let me say I'm going to do this. So it says zone is going to be US Central 1B. Then the command is gcloud container cluster create. The name is given as online boutique. The project ID will be picked. The zone will be picked. And here, like in Amazon, we have T2 micro. Here we have E2 standard, and the number is 4. 4 nodes, worker nodes will be there. Okay. So let me take this guy and come to my Cloud Shell. Okay, let me see one thing. Okay, I think there's something which is missing. Let me say CD. I think the project setup is not correct. Let me do this again. Paste this guy. Then the second command. Okay, now let me go ahead and create the container. So to create the container, I have the command which is mentioned here. Take this command, and obviously you can increase or decrease the number of nodes and all. So this time I'm using my Cloud Shell to create the container or create the cluster. Let me come back. Cloud Shell, paste it here and let it run. So it says that I am creating a cluster with the name as online boutique. It is going to get created in US Central 1B and it is working. So it will take some 5 to 10 minutes to work on this or to bring this up. Once this is up, we will do other things. Alternatively, if you don't want to create a cluster like this, you can come here and you can do a create cluster. So that also will work. Okay. The only thing is I am trying to use CLI or command line interface and willing to create this from the Cloud Shell or command line interface. But all the other ways will also work. It is not like this is the only way to work. All the other ways will also work. And here there are 4 node cluster and it is getting created in US Central 1B. So it will take another 5 to 10 minutes to create this. And then once it is ready, you very well know that you can click here and you will get 3 dots, click, and then it will ask you to connect. So we will wait for this to come up. And it says it is working. So let's wait. Now, meanwhile, I'll take questions. If anybody has any questions, please go ahead, because it will take some time for this to come up. So just to revise, I want that the microservice communication should be done properly. One microservice should be able to communicate with other microservice, not only within the cluster, but also outside the cluster. And when I say the non-functional requirements, I'm basically concerned about encryption, routing policies, failover policies, access control, and logs. So these are the things which I want that should be taken care by Istio or Istio envoy proxy. So first thing what I'm doing is I'm going ahead and creating my cluster. So this is what is happening right now. The cluster is getting created. It is working. Once the cluster is created, we will go ahead and put our content, means we'll install our Istio. So when we say that we are going to install Istio, these are the commands or these are the stuffs which we are going to do. So when we say we are going to install Istio, there are components like Istio core, Istio D, and then Istio add-ons. Then we configure the envoy proxy and finally we deploy our microservice. Okay, so all these things will happen, but once the cluster is up and running. Okay. Now, anyone has any questions, please go ahead.
Because this Istio is used for only microservices.
Yes, it is mostly used for microservices alone. Because see, the entire purpose is that there is a distributed application and you want that this distributed application, which is running across several containers or several clusters, should be able to talk to each other. And this is exactly what they are talking about here.
Okay. And like normally, like what are the real-time examples of the Kubernetes platform? Like one is microservices used. Generally, I'm asking, one is like microservices purpose, we will use the Kubernetes platform. Other than that, normally, like what are the other examples like that we use Kubernetes, Docker, and all this DevOps platform?
See, any architecture, it can be Uber, Amazon.com, Google itself, any architecture which is using microservice based architecture. It can be a mobile app, like I told Uber, it's a mobile app, or it's used for booking cabs and all. Amazon, it is used for online shopping. So I'll say 90% of the applications which you see around you, they are using Kubernetes. In fact, there is a game called Pokemon. This is also using, like, this is one of the very popular games which came at that time. So this is also using Kubernetes. So for me, I will say 90% of the applications are using Kubernetes. And also one more thing, if I simply come here and say KTS market share, you will be very much market.
That means mostly in our environment, like outside environment, mostly people use microservices. Can we say like that, like
yes.
microservices like Uber, Amazon, or whatever the other applications like Swiggy, Zomato, all other applications we are
Swiggy,
using.
Zomato, everything what you're seeing is using microservice based architecture. One thumb rule which you can take is any application which is multiple tier, means there will be a front end, then middle layer, then back end. Any application which works in that way is using Kubernetes. And that's why it is saying 96%.
Okay.
Like so because can you show one the multi-code program once just to see how it looks?
Multi-pod program in the sense?
No, you showed right with Python, Go.
No. It is not like that. See, it is not like in one program or in one container only everything is kept. It is not like that. Wait, give me 1 second. I'll show you something here. See, if I go to Kubernetes manifest, okay, and here, let me say I'm going to this card service. Okay, here they are using an image called card service. Okay, so suppose I take this image, okay, and I go to hub.docker.com. and try to find it out what that image is. So let me say somebody has cloned it. So this is the one. Okay. See here. So I can come here and try to find out tags. Latest.
Mama.
So this is what is written. See here, it's a
Mama.
Python script. Okay. So like this, not every code is a Python script, or not everything is a Golang. Okay. It's a combination of all these things.
Okay, so each microservices will have different programming languages,
Yes,
correct?
very much possible.
Yes.
Very much possible.
Okay, so these Python codes will be written by the core developers who are developing the application.
Yes. See, as a DevOps engineer, the expectation will be that you should at least know what is what. Suppose there is a scenario where the developer is not there today. Suppose he's on a sick leave. Suppose. So some problem happened. So at least you should know that where the code is and how should I work with that. That much knowledge you should have. Okay. So that is the expectation from you. So as of now, if I see here, this is ready. The name of the cluster is online IP. This is the master IP, and the Kubernetes version 1.22 is running. The 4 nodes are there and the status is running. So this is running right now. Okay.
Yeah. So Vikas, can I ask the question now or after this one?
You give me some time, because now I will go for another set of installation. And whenever we go for installation, you will see that it is going to take a good amount of time for the installation to happen. So let me go ahead with that. So what I'm going to do is I am going to go inside. Okay, let me create a folder. So let me take these guys one by one. I'm going to create a folder. Paste this guy. Then CD, which I did not show you. CD. One second. ls minus L. It is saying this Istio installation is already there. So rm minus rf Istio installation, delete first. Then let's go and follow this. So I'm going to create this folder. Paste. Then I'm going to go inside this folder. And here I'm going to say wget, and I'm going to copy this guy. This is my latest release. Copy this, copy the link, and execute it here. So wget means pull the content and put it here. So you will see that it is getting pulled. ls minus L. You will see this Istio is present here. Now you can see it is tar.gz, means it's a tar file plus zip. So I say tar minus xvzf, and this guy Istio. So it will be unzipped. Now if I come back here, I have 2 versions. One is the zip and the normal one. Let's go inside the normal one. And ls minus L, here you will see the entire content. Now in this entire content, I'm interested in this bin. Okay, let me come. I'll share this entire thing with you. Okay? Now, if you simply come here right now, I want to run this command istio ctl, but it will not work. It will give me a, okay, it is because I've installed earlier, so it is working. But when you start for the first time, no, it will not work. So I have to add it to my path variable. So I have to do something like this. Wait a second. I have to do something like this. These are some standard stuffs which you do. So basically here what you're trying to do, in your generic path variable, you're trying to add the path where you have installed Istio. Now, if you come here and say echo dollar path, PATH path. So there should be no space here. See here, this is what I want, that in my path, this guy should be added. Once this is added, okay, I will share this document with you. Okay. I can go ahead and check all these things. So let me just show you before I do any installation. kubectl get pods. So as of now, there is no pod available. Okay. Now I will install Istio. How? I will say Istio ctl install. This is the command to install Istio. So what it will do is it will go ahead and install Istio. This will install Istio 1.13 for you with Istio D and Istio core and Istio gateway. So these are the three components which will be done. Do you want to proceed? Say yes, and it will go ahead and install Istio for you. So now wait for Istio to be installed. It will take 5 to 10 minutes. Some 3-4 components will be done. Once that is done, I can go here and check the pods, and you will see 2 new pods have been generated. So this is the step number 1, where you install Istio. Then you configure envoy proxy, and then finally you deploy your application. So we will go to those, but one by one. Now, any questions till this point of time?
Sir, you told that on the options of the code developer, we need to identify the issue and then modify it in the code point of. So as a DevOps engineer, as of now, I'm not good in the coding.
See, I will be very clear, and I will say that when I say DevOps, little bit of development will be there. See, 99.9% nobody will ask you to sit and write the code, or nobody will ask you to go and debug the code. Okay, but little bit of knowledge you must have. Likewise, I will show you in real environment if there is a problem. Okay, at least you should be able to know, go in the logs and check where the problem is. At least if the developer is not there, you should at least tell that, okay, you know, I think this is the problem. So that kind of thing is needed. Obviously, day one, when you join the company, you will not have that skill 100%. But gradually, when you keep working, that expectation will come. Okay. So DevOps itself is evolving, or it is coming up. So don't think like you will have to go and write the code. Not like that. But slowly, when you are old in the project, they will expect that you should know how to write the code. That was also there. So let me move on. So here it says Istio 1.13 has been installed for you. Okay. Now, once it is installed, I can run this command, Istio ctl, and you will see 2 new things have come up. Ingress gateway, Istio ingress gateway, and Istio D. So these 2 are running. Now this is done. Now it says you have to configure envoy proxy, or you have to inject your envoy proxy for all the non-functional requirements. So you have to run this command. These are some standard commands which everywhere they will run. It is not like because we are doing a demo project, we will be running and others will not run. They will have to run. And here, if you see namespace default has been labeled. How to check this? So you can check here. Is this right? So here, if you see Istio injection enabled. So you have enabled, first you installed, here you installed, here you have enabled Istio. Okay, Kubernetes cluster is already running. Now the third step is you deploy the application. So how will you deploy the application? So let's come here. Kubernetes manifest. Keep going down here, not here.
Because can you go to Cloud Shell?
Give me one minute. Okay. So it says you have to go here, right? Microservice demo. Let me go to the starting ls-l. This is where my code is, microservice demo. Here I have to go to my manifest file, cd mani. MANI. What is that file name? ls-l. So here I have Kubernetes manifest. So I have cd Kubernetes manifest. Now here, there are the files which I want to run. The kubectl commands will run on these files. So now let me run it. Kubectl kubectl apply -f dot means whatever is there, I want to run everything. Now see what will happen. Deployment service. So these many things will start the creation, or these many things will start getting created. One problem which can come is this low resource request. So your machine, like 4 nodes may not be enough. So you may have to increase the nodes, but let's see if it runs. So this is done. Now, if you come here and say kubectl get all, you will see a lot of things are getting created. See here, these many deployments are getting created. These deployments are not nothing but everyone is one microservice. Like email is one microservice, payment is one microservice, Redis is your database. Then you have the cart. Then many times it shows you the advertisement. So ad is this, front end is there. Okay, load balancer is there. So like this, each has its work to do. More importantly, if you see here, this front end is load balancer and all the others are cluster IP, because I don't want to expose anything outside, right? I just want this guy to expose, and internally all the communication will happen. So all these guys are my cluster IP. Then this is what is important. So if you see here, it is saying this is my pod for advertisement. This is pod for the cart. Here there is some problem with the image pull back off. Let me see what is the problem here. But more important thing is there are 2 containers which are coming up. The replica, see here, the replica set is saying I need 1 container. But here, if you see, there are 2 containers coming up. If you go inside any one of these, let me say I go inside this Redis one, okay? Copy kubectl describe, paste this guy, paste this guy. Okay, so if you go inside this guy and let me come to container section. See here, if you go to container section, you will see 2 containers are there. One is Redis, which is taking care of the functional requirement, and the other guy is Istio proxy. Istio proxy is my Istio proxy, which I have used via Istio sidecar. So in all the applications, you will see that there are 2 containers running. So if I just come here and say kubectl get pods, you will see that 2 by 2, and here it is 1 by 2, means one is only running, one is yet to run. And more importantly, the second one is my sidecar, or the second one is my kubectl, the second one is my Istio sidecar. So it is taking care of the non-functional requirement, and the first one is taking care of the functional requirement. So let me just go and check why it is failing. Kubectl describe pod, and this pod, let me see why it is failing. Is the pod not available, or what's the problem here? Next. So here, if you see, failed to pull a add service RPC error, authorization error. So it is not able to find this image. Basically, see here it is clearly telling failed to pull the image AD service. Okay, and either you don't have access to pull it, or authorization is the issue. So there is a high probability that this image is not available and we are trying to pull this image. So that's the reason it may be failing. So this is the problem here. So let me clear all these things. Okay. And here, if I come here and say kubectl get SVC or get service, I can see this load balancer is running. This is my load balancer. And here also, they're saying everything will run. So they have not installed Istio here. So they are getting only 1. I installed Istio, so I'm getting 2 by 1. And here it is saying that you go and take the IP address of this guy. So let me run this here. Cloud shell. paste it here. So this is my external IP address. Try to run it here. Let's see what we see. No, it is not responding. So let me do one thing. No, this is not responding.
Is there any problem with the project ID?
I don't think there should be a project ID problem. See, this problem I can tell you. See, kubectl.
No, I saw that you have not added the project ID in the when
No,
you are
I added in the
this
beginning
Google.
only. So it is
No,
not.
no, after that, there is one more the same project ID to be added.
No, that is, it will take by itself. You don't have to add that. Okay, or let me just do that also. We can try that also, not a big deal. We can do one thing.
Uninstall again and reinstall.
Yes.
Delete the
No,
bot.
that is not required. Wait. kubectl delete delete -f dot. So I'm deleting all whatever I've created. Okay, all the things will get deleted. Now
The second one which you have added, no, Google
Yes.
app something.
Let
There you
me-
have forgot
yes.
to add the project ID.
Let me come back here. I just exactly know what you're talking about. So this $project ID.
Second one. Yeah, that is the one.
Let me come here. Ideally, it should not be a problem. Okay. Why I will tell you, because this guy should take it automatically. Still, let's try and format, dual wrap. Let's try this.
And then you have to remove $sign because it is stored for store.
Okay, wait, minus project. Why to remove $? Okay, there's not a value here. Okay, let's see. $value. See, it is giving an error. It should be.
We are in the Kubernetes manifest folder. You need to come back, right?
That is okay. You can run it from anywhere. That is not a problem. That is not a problem. See, this is okay, man. This is not a problem.
But the issue was container, we couldn't
Yes.
access the image, right? So
Correct.
that means if we give the authorization, then probably we log into that ID.
See, this is project ID, means if you say echo $, this project ID, paste this guy. See here. So this project ID has the value. So this guy is correct. It is not the problem with this guy.
So because of the pods which were getting error, is the reason for the load
So
balancer
because
to
of the
show that?
containers, it is not able to.
Yeah, because the pods were not.
So I think the containers are not reachable. So that's what it is giving a
So
error.
maybe you will install again. So
No, I'll tell you
it
what
will
is-
pull the image.
So wait. Paste. This is correct. There's no problem here. Okay, this is okay. See, the problem is, let me say ls-l Istio installation cd microservice demo cd Kubernetes manifest. So here, if you run it, ctl apply -f dot. So it is saying the images which you are trying to find out, I'm not able to figure out those images. So basically what we have to do is we have to change the names there. I'll tell you what has to be done. Okay. See, kubectl get all.
So my assumption, like if pods are not ready, like how load balancer works?
No, it will not work. So if you remember, we had something called pod init. We told that unless and until the pod is initialized, ready to take the traffic, don't push the traffic. So
Yeah.
that will be there. Okay, copy. Come here and say kubectl describe. So this is how you debug. Okay, you got some error. You go to the pod and see what went wrong. So here it is saying this is the error. So if we read the error, you will clearly come to know that that particular container is not what it is able to find. Format what wrap.
The image is not pulling it from anywhere else, right?
Yes, it is not able to find this image. Basically, it is saying
No,
failed.
no. Where it is not able to find.
It is
From
not
where
able
it is
to
trying
find.
to pull.
See, we are running on a Google Cloud environment. So the first
Correct.
preference will be given to GCR. It is not able to find in GCR. It is not able to find it in Docker Hub. So these are the two places where it is not
Is it
able
a
to
private or public image? Because it is showing as a permission authorization failed.
So that can also be a scenario. See, there are two problems here. Can be two problems. One, the images which we are trying to find out is a private one. So we don't have authorization for that. This can be one failure. The second is the image which you're looking at is not at all present. So here it says Docker IO library add service latest failed to resolve the reference, means I'm not able to find it in docker.io. So
Then we can go and check it in the docker.hub, no?
yes,
Whether
yes, we'll check. We're doing that only. So now I will try and see whether this particular thing is there or not. So let me come here. I think so what they might have done is they might have made it a private one. So hub.docker.com here. Here, sorry. Copy. Paste this guy. So if you see here, add service with this particular name, there is no image. Yes, people have created this image by their own names. So let me say, if I go ahead and say recently updated, let me say I will take this guy's image, RAQUIO. Okay, if I take this guy's image, then it will be able to find it out. So like that, for all the images, I have to make changes. So let me come here. And this is what it is causing a problem, right? So now rather than setting kubectl describe, I will say kubectl edit. Edit. Okay. Now escape I, go in insert mode. Look where this image is being referenced or called out. Container.
it is under app.
Yes, let's see.
Label under label.
See
App
here.
is there.
Here it is there. So here the image is add service. What I will do is I will change the image and I will make it RAQUIO \add service like this. So let me just do that. RAQUIO \. Okay, then I will simply come out of this. Okay, so it has been edited. Now go ahead and say kubectl get pod. Now let's see what's the scenario here.
No need to do apply again.
No, you don't have to do apply again. If it is against,
Again, it is taking full image add service.
when you do edit, no, it will automatically take it. So still
But
it
still it is taking the old image. It is looking for add service, not the ROQ.
correct. It is not taking this.
I think it is only authorization issue.
So in that case, what I will do is I will have to make changes to all these images, which I will do in the background. So I will go to Kubernetes manifest, and here I have to, for each one, I have to make changes. Like, let me show you for at least one here, and then later I will do. So let me say I'm going to this add service YAML, so nano add service YAML. And here you have to make the change. Name, kind, security, container. So container. Here can you see the container port? Where is the container name? Selectors app deployments, a deployment spec match label.
The images are below.
Below, yeah, container security name. Privilege.
Here, sir,
Here. So here we have to do something like this. We have to change this guy. What is this guy's name? RAQUIO. RAQUIO. Front slash or backslash. Backslash. Okay. Control X, Y, enter. Now you have to go ahead and say kubectl apply -F. So you have changed your ad service.
Because is this images in your private hub?
Tell again.
No, is it available in your, might be in your hub, Docker hub? You have your own Docker hub,
No,
right?
this is not in my Docker hub, but whatever I'm pulling or trying to pull here, it is a public image.
What we can do is we can download and keep it in the local repository in the
Yes.
GCP.
So this is again one more option which we have. So I think this is also they are not able to pull. So what I will do is I will take all the images, keep it in my local in the sense in my GitHub repo or in my Docker hub repo, and from there I will pull it. Okay, and then it should work. Or just to make it run without Istio, I just want to run it without Istio. If I have to, let me do one thing. Let me delete this cluster. I'll quickly do something and show it to you. It is not able to take that guy, but I'll show you something which can be done quickly. So first is I'm trying to delete this, whatever I have created. I'll again go back here, clear everything. And this time I will run, but without Istio. Okay. So let me just close this guy also. Leave. Come here. Let's run from here. Open Cloud Shell. Wait a second. Cancel. Open new window. This is Cloud Shell. Confirm. Then go here and take these two guys. Okay. So this project is already set here. Okay, this project is set. So I need not run this thing here. Clone is also not needed, because if I say ls-l, I can see I am already here. cd Kubernetes manifest. Here, kubectl apply -F. Let me run this and see what happens. I don't think it should run. Wait a second. There is one small problem. This has not been done. I should have done this guy. Because as of now, there is no cluster here. Paste. Set project ID. Okay, it is asking set project ID. Let me do this guy again. These two lines is what I have to run again. Paste. Okay. Then go ahead and run this command again. Wait. This is.
But
So
that project is got deleted, no, from your side.
But I am creating a new one now. Paste this guy. So I'm creating, it says G counter already exists. Okay, I'll give a different name in that case. I'm giving a different name here. Demo. Okay, so I'm creating a new cluster, same configuration, only I'm not giving demo right now. Sorry, only I'm not using the same name. I'm using a different name here. So this is coming up, this is getting deleted. So we have to wait for 1 or 2 minutes for this to come up.
Okay, so bit confused what you have done, sir. Like, can you tell me?
See, in this entire architecture, in this entire process, we are trying to implement this guy. So this is a microservice based architecture which we are trying to implement. Okay, so here if you see, there are many front-end applications, or these are microservice based applications. Now, when they talk with each other, there are concerns related to your security, load balancing, monitoring, and metrics management. Okay, so all these things I want to address. So address all these things, I would like to go ahead and implement Istio. The moment I go ahead and implement Istio, Istio comes with two components. Okay, one is Istio sidecar. So if I simply come here and say Istio, Istio comes with, it will take care of your observability, means your monitoring, the traffic management, the security, and routing policy when you are using a service mesh. Now it comes, what is a service mesh? So when two microservices talk to each other, they need an envoy proxy. This envoy proxy is nothing but it will make sure that your content is using all those non-functional requirements. And we say non-functional requirements, we were talking about these non-functional requirements. Okay, then what we did is we went ahead and we wanted to deploy the cluster. So when we say deploy the cluster, we had this piece of code. And if you go inside this piece of code, Kubernetes manifest file here, you will say these many microservices are there. Each microservice represent one piece of code. So if you see here, this is a deployment file, and this is trying to run this particular image.
This entire code will be given by the developer only, no, sir?
Yes, developer will give, but again, I'm saying many a times if they will ask you, then you should be able to write. Not at least in the beginning, but later.
Again, we are calling as a YAML file, right?
Yes, this is YAML file only. So
YAML file will be written by DevOps engineer only, right?
yes, YAML you will write. This is your image. This is your deployment file. And finally, this is your service file. Okay, so you will be writing this.
Sir, in beginning, we are creating 4 nodes. So it is for Kubernetes cluster, or it is only like we are creating EC2 in Amazon, AWS, we are creating instances.
See,
so
when you say nodes, okay, these are
Yes.
nothing but machines. This machine can be on GCP, it can be on Kubernetes, wherever you want, you can use it. So it is up to you where you want to.
It is we are simply creating machine, and then after we are installing Kubernetes.
Yes.
Okay, sir. Thank you.
In AWS, I can simply use EC2 instance and run this.
Yes, but it will depend on the instance size. Means how big your instance is. If it is like T2 micro, probably it will not run, because these machines need a lot of this thing. So if you see here, as of now, the master health is going on. So I'm waiting for this to come up. And once this comes up,
Because normally we created like many YAML files, not created YAML files, 1 by 2 containers creating, right? What is this other container? 2 containers are there, right? In that
no,
normally.
here if you see, it's a full-fledged application. See, for recommendation, there is a different container. Payment, there is a different container. Email, there is a different
No,
container.
not here. Like previously, we deleted it, right? Some YAML files we kubectl apply f dot we given, and then after that, many containers services deployments created,
Yes.
and then in that 1x2 are there, right? 1x2 created.
I'll show you that. One is for sidecar container, and the other one is for your actual stuff.
Okay, and that means every deployment and every in the every pod there will be a kube envoy, like proxy envoy. It will be like
for every deployment, on top of what you do, there will be a kubectl envoy proxy.
Okay, that means 2x2 means one is a normal container, and then
one is for the functional requirement, the other one is for the non-functional requirement.
Okay, like why we are creating, we can create for load balancer, and then load balancer service is there, right? For that it is,
but
we can
here
create
you are distributing the traffic. No, this traffic has to be distributed. Same
okay
problem. The image, it is not able to pull, so I have to make sure that I have to give the correct images. So anyhow, we'll go ahead and give the correct images here. So I have to change the setup here. I think it is not able to pull the images. So all the images which are present here, it is not able to pull that. Copy. Can I do one thing? I'll give you a last try. Okay. Let me clear all these things. CD. RL minus
Instead
RL.
of doing this application, we can do some other application, whether we can see the good result.
No, man, it's not about seeing good result or bad result. It should be a working application. That is more important. Give me 1 minute. So I'm trying to directly pull from this thing, what you say here, Google Cloud Platform, this thing, okay. Paste. CD microservices, then you have manifest. When it is manifest, ls minus l, same content, kubectl, apply minus f. Let's see here if it is causing a problem. Same problem here also. So basically, what is the problem? I'll just show you. Kubectl get pods. If you go to the pods, here it is not able to pull the image. Image is not being pulled. Why? Because it is saying either it is private or it is not available. So I have to check why it is not getting pulled. And once I have a solution to this, I will come back to you probably Monday or day after tomorrow. Oh, sorry, Monday. Yes, Monday is the class. So I'll come back to you with the solution to this on Monday.
Sir, if we are installing stereo, so it will take like we are seeing, we can see it is 2x2. So space is double. It is taking double space.
See, space-wise, yes, it will take, you cannot say double space, but yes, it is taking more space. One is for your functional requirement, and the other one is for your non-functional requirement, like encryption, then load balancing and all. But that is also mandatory, right? So you will have
Can we set the storage space limit?
Yes, if you see these files, there is a limit put on all the files. If I come down here, even it is manifest file. See here, a limit has been put on these. Like the memory cannot be more than 300 MB. Like this limit has been put.
For non-functional thing.
For the non-functional thing, that is by Istio itself. You don't work with that. This Istio control plane will go and give you the envoy proxy. You don't manage that.
Means based on the what is the size, it will automatically adjust. The Istio will automatically adjust and create the other non-functional pod.
Correct.
Okay. And also, sir, regarding this Kubernetes cluster, when we install the Kubernetes cluster, so whatever the data in the worker nodes will be taken care by the etcd. That is like a storage type. So when we install envoy Istio on that part, like how the data it will collect with the help of microservices, and where that logs and where the data will be stored then?
See, it is not getting stored inside the cluster, in the sense in the etcd. This Istio has its own control plane. If you see this guy, Istio has its own control plane. So all the non-functional related data will be stored in Istio control plane. To be very precise, Istio D or the Istio component, Istio D is where it will get stored.
Okay. And when you are installing the cluster, after installing the cluster, after installing the Istio, there are two pods are created. I am not sure why the two pods are created.
If you remember, I told when you install Istio, there are some components which are automatically created. Istio ingress, I think that is gone now, but I can show you.
Yeah, second time we did not create it, right?
But second time we just missed, we just skipped the Istio part. That's why. So here is where it was there, but get pods.
Okay, from this, it is taking the second pod. You mean to say, after creating this SEO system, after giving the apply F in for all these services deployments, it is taking the second pod. You mean to say?
Yes,
that
the second
NV
see,
proxy.
as of now, you see 1 by 1 or 0 by 1. This is because I've skipped the Istio part.
Istio
But
part, yes.
first time when I was doing it was 2 by 1. 2 by 1 is the
Yes.
second part is coming from Istio. That is Istio sidecar or
Okay.
Istio envoy proxy, or you can say the non-functional requirement of your pod. Okay.
Basically, it is a backend and a front end both.
Kind of. More of a backend only. Don't say front end. It's more of a backend.
Istio is for backend.
Backend only. Yes.
How the microservices will be connected each other?
That's what this guy is doing. No, this guy is doing that only. No, Istio is doing that only, right? See, there is microservice A, microservice B. They both want to get connected. This is what envoy proxy is doing. They are connecting both of them together. They are allowing the traffic to flow from one channel to another.
Okay, this envoy proxy also talks to the actual Kubernetes cluster
Things
also,
will be
like.
taken care by envoy proxy or your Istio sidecar.
Okay.
That means there is an internal, two pods are there. In internal, one pod is there, that is NV proxy, that is connecting to all the deployments which we created, right?
Correct.
And this is within the cluster, because
on top of the cluster. On top of the cluster. I told whatever you're doing on top of the cluster.
Yeah, on top of the cluster. Like how it is connected. Like we did not talk about that. Like previously, we were talking about the payment.
This is a tool. So the internal things we are not concerned about. We just use the tool. It is a tool. So it is like how kubectl internally works. So that I'm not concerned. I just should know how to use it.
No, I'm not asking that. Like you told right previously while explaining, this is the application, shopping cart application. Like all the things adding to cart and viewing application will be in the one cluster. Suppose if we go to the payment mode, like Visa transaction or any other thing, it will go to the another cluster, right? You said
so here,
payment.
as of now, we are using only one cluster, and within the cluster only, we are trying to map everything together. We are not going outside from our Kubernetes cluster in this example.
Okay.
In one cluster, 4 nodes, right?
4 nodes are there. Correct.
So, sir, why we are creating 4-node cluster if it is not?
It is up to you. You can create 4 node, 20 nodes, whatever. See, if your application is very big, might be having 20 worker nodes. If it is small, only 2. So it is up to you how big your cluster is or how big your application is.
It is chargeable if we get.
I told in GCP you get 300 credits. If you use that, it is not chargeable. If you go beyond that, it is chargeable. If you do in AWS, it is chargeable.
Okay. So sir, why we are not creating 6-node cluster if it is getting low resource request?
You can. It is up to you. Last time when I ran, it ran in 4. This time it is not running. It is giving me. So probably next time when I do, I'll do it in 6. You can do. It is up to you. Within $300, whatever you want to do, you can do.
Okay, sir, thank you. Yeah,
Yeah,
regarding the
all-
parts, the image full of error, we are getting two types of error when you go with the
Yes.
kubectl get parts. So those are similar, but two kind of error. Like what
Yes.
is the
So
difference?
it is either that it is. So it is either that image is not reachable or I don't have access. So I need to check. As of now, I'm not very sure what is the actual reason for that.
Okay.
Need to check that.
any alternate for you?
You have to get that image. If the image is not there and you're trying to pull, then it is a problem. So I need to
Because,
check. Actually, I'm also facing it for the first time.
Any alternate for issues or only we have to use
No,
Istio?
Istio is the one point of contact. There's no solution alternate for this as of now. Fine. We meet on Monday. We continue from there. See you then, guys.
Thank you, Gus.
Yeah.